A hearty welcome to all of you. Let's move on to the next topics of our chapter, metals and non-metals. So far we have studied about the physical properties and chemical properties of metals and non-metals. Today we will study about a different thing, which is displacement reactions. And then we'll see what is the reactivity series of metals. Then we'll also do an experiment which will demonstrate the displacement reaction. And we'll see the examples of displacement reactions, and we'll finish our chapter with the uses of metals and non-metals. Displacement reactions. A reaction in which a more active or a more reactive element displaces a less active element from its compound when reacted together is called a displacement reaction. So what basically happens in a displacement reaction is that a more active element will displace a lesser active element from its compound. For example, here is a equation, here is a reaction of X plus YZ. Now here in this reaction, X is more active than Y, and therefore this X will replace Y and form a new compound XZ along with the element Y. So here you can see that the more active element X has replaced the lesser active element Y from the compound YZ and thereby making a new compound XZ. The principle of displacement reactions is based on the reactivity of metals. With the help of activity series of metals, we can know which metal will replace the others. Thus, we can say that displacement reactions help in determining the position of a metal in the activity series. Now, what is this activity series? Let's see. Reactivity series of metals is a series which lists metals in the decreasing order of their reactivity. And it is also called activity series or reactivity series because it is based on their capacity to react. It will show how much reactive they are to perform any reaction. Metals which are higher up in the activity series can displace those metals which are placed below them. So from the activity series you can easily find out that potassium can replace sodium and sodium can replace calcium, and potassium can replace sodium as well as calcium and all the metals which are placed below potassium, and same is with other metals. So the metals which are placed at the higher position, which are at the top like potassium, sodium, calcium, magnesium, they are most reactive, they are highly reactive. Whereas the metals which are placed at the bottom, that is gold, silver, mercury, copper, they are least reactive.
Displacement reaction. A substitution or displacement reaction is a chemical change in which atoms of one element replace the atoms of another element from the molecules of a compound. Let us take up an example. When an iron knife is dipped in an aqueous solution of copper sulfate, a layer of reddish-brown precipitate is formed on the iron knife. The iron from the knife, being more reactive than copper, displaces it from the copper sulfate solution. The copper so separated gets collected on the surface of iron knife. Activity. Take 500 milliliters beakers and add 20 milliliter water in them. Label the beakers as 1, 2, 3, 4 and 5. Add 5 grams copper sulfate to beakers 1 and 2. 5 grams zinc sulfate to 3 and 5. And 5 gram iron sulfate to beaker 4. Now add some iron nails to beakers 2 and 5. Copper turnings to beakers 3 and 4. And zinc granules to beaker 1. Then keep the beakers undisturbed for some time and observe carefully. You will observe that the color of the copper sulfate solution changes in beakers 1 and 2. On the other hand, no change is observed in beakers 3, 4 and 5. In beaker 1, zinc Zn replaces copper Cu from the copper sulfate CuSO4 solution to form zinc sulfate ZnSO4 and copper. Because of this, the blue color of copper sulfate disappears and a reddish-brown substance, that is copper, gets deposited at the bottom of the beaker. Similarly, in beaker 2, iron replaces copper from the copper sulfate solution. Hence, the color of the solution changes from blue to green and a reddish-brown substance gets deposited on the iron nail. We conclude that displacement reaction takes place between the more reactive metals to the less reactive metals of salt solution.
As we have seen in the previous activity where we have kept an iron knife in copper sulfate solution. The copper sulfate solution CuSO4 is blue in color. When we left the knife for some time in copper sulfate solution, we observed a reddish brown substance was formed on the iron knife and the solution became green. Why does this happen? Iron being more reactive than copper, it displaced copper from the copper sulfate solution, and the copper thus separated, it got deposited on the surface of iron knife. So we can represent the reaction as iron plus copper sulfate solution. It will form iron sulfate FeSO4 plus copper, and this copper in solid form got deposited over knife. This is iron sulfate. This is copper sulfate. So this is showing a displacement reaction. Iron being more reactive than copper, it replaced copper, and the copper thus released, it got deposited over knife in the form of reddish brown layer. Let's do an activity to demonstrate the displacement reaction, and for this we need 5 beakers which are of 100 ml each, and we need some metal samples like iron nails, aluminium strip, copper turning, zinc granules, lead, magnesium, etc. Then we'll need copper sulfate solution, zinc sulfate, iron sulfate solution, silver nitrate solution, magnesium sulfate solution, and test tubes. Now what we have to do is, first we have to take 5 beakers and we have to label them as A, B, C, D and E. And in beaker A we have to put copper sulfate, in beaker B zinc sulfate solution, in C iron sulfate solution, in D silver nitrate solution, and in E magnesium sulfate solution. Now we have to test for each of the metal for its reactivity. So we'll start with zinc. First we'll put piece of zinc in each of the test tube. We will take these samples in 5 different test tubes and then we'll put the metals one by one. So first we'll test for zinc and we'll see that zinc will displace most of the elements except magnesium. When zinc metal is added into copper sulfate solution, it displaces copper to form zinc sulfate. Zinc, it reacts with copper sulfate solution and displaces copper, being less reactive than zinc, and forms zinc sulfate solution. And the copper which is released after this displacement reaction, it gets deposited at the bottom of the test tube. And when copper turnings are added into zinc sulfate solution, nothing happens. And this shows that zinc is more reactive than copper. When zinc could not displace magnesium, so zinc is less reactive than magnesium, and in this way we can test for all the metals and we'll see their reactivity series. There are many examples of displacement reactions. A few of them are like replacement of a metal in a compound by more active element. For example, iron reacts with copper sulfate, displaces copper and forms iron sulfate, and copper is released. Then replacement of hydrogen in water by a metal like magnesium. When reacts with water, it forms magnesium oxide and releases hydrogen gas. So here magnesium has replaced hydrogen. Then replacement of hydrogen in acids by metals. For example, zinc reacts with hydrochloric acid, displaces hydrogen from the hydrochloric acid and forms zinc chloride, and hydrogen gas is released. Uses of metals. The uses of metals are related to their properties. They are made into jewelry due to their hard and shiny appearance. They are used to make cooking vessels because they are good conductors of heat. They are used to make electrical cables because they are malleable, ductile, and good conductors of electricity. They are strong, so they are used for the construction of bridges and houses. They are sonorous and therefore they are used in making bells to produce ringing sound. Zinc is used for galvanizing iron to protect it from rusting. Chromium and nickel, they are used for electroplating equipments. Metals are used for making different types of alloys. Mixed metals. Metals such as aluminium are used for packaging materials, and mercury is used in thermometers because mercury is the only metal which is found in a liquid state at room temperature, and because of its shiny lustrous property it is used, because of these two properties it is used in thermometers to measure temperature. There is an abundance of nonmetals like carbon, oxygen, nitrogen, and hydrogen in nature, and these elements are essential for the existence and sustenance of life. For example, oxygen, which is the life gas, it is needed by all the living organisms for respiration. Water, we all depend on water, and it is formed by the combination of hydrogen and oxygen. Carbon dioxide, again a compound of carbon and oxygen, and it is used by plants to prepare food. It also traps sunlight and keeps the earth warm. Plants need nonmetals like nitrogen and phosphorus for their growth. On the other hand, nonmetals are bad conductors of heat and electricity, and therefore they are used as insulating cover around wire cables and to make handles of cooking vessels, like bakelite. Diamonds, they are used extensively in jewelry and for cutting and drilling tools. Neon, it is used for electric advertising signboards. So in this way we have finished our chapter metals and non-metals, where we have seen all the physical and chemical properties of metals and non-metals. Hope you all have understood it. Thank you.